Okay, Science 10, we're going to look at single replacement reactions. First of all, just how to recognize them, but ultimately we want to finish these off and then we want to balance them correctly. Hydrogen here is basically going to replace this aluminum, so we're going to be able to get pure aluminum out of this reaction. This nonmetal, bromine, and that nonmetal, iodine, they're going to just be changing places simply. And ultimately, the hydrogen here is going to link up with the iron. But let's start up here. Again, you always want to have your periodic table in front of you. You need to make sure to be focusing in on it, looking at the reaction. So you've got aluminum, and oxygen, you got hydrogen. Kind of focus on those three in this particular one, but we suspect it's a single replacement. And ultimately, it is going to be a single replacement. This hydrogen can definitely link up with the oxygen. It's going to be able to make water, right? So ultimately, that's one of the things we'll just do right here. We know good old water, H2O, liquid. All right, so then we're just left with aluminum. Al, metals are always monatomic, solid. Now it's just a question of balancing this off. Looks like the oxygen again is going to be kind of a tricky one. If I put a 3 here, I wonder if that'll do it. Sometimes you have to do these a couple times to get them right, but if I put a 3 here, I'm going to have 3 oxygens. I'm going to have 3 times 2, I'm going to have 6 hydrogens. But, you know, I can just simply match that over there with a 3 there. And, oh, that's not going to work because I need to put a 2. Wait a minute, that just might work. If I put a 2 here, yeah, actually this might work. Okay, let's check. 2 aluminums, 3 oxygens, and 3 times 2, 6 hydrogens, 3 times 2, yeah, 6 hydrogens. 1 mole of aluminum oxide combined with 3 moles of hydrogen gas will give us 2 moles of pure aluminum and 3 moles of water. This reaction would obviously be done at quite high temperature. Okay, another example of a single replacement. We've got the nonmetal bromine and the nonmetal iodine. The bromine and iodine are simply going to change places. So let's make sure to get the proper formula for potassium and bromine. Potassium is +1, bromine is -1. That's going to be a simple 1-to-1 ratio. So that's just going to be potassium bromide, KBr. Doesn't really matter where exactly I put this. Definitely it's going to form a solid normally, but we'll just put aqueous. We should actually check our solubility table on that one. And yeah, if you look that up, that's definitely going to be soluble, so aqueous. And we're left with iodine, because, you know, the bromine kicked the iodine out. Iodine, group 17. I2, it's a solid, that's its state of matter. Let's look if we need to balance this. Yeah, I got to put a 2 here because I got 2 iodines. And oh yeah, and then I just got to put a 2 here, right, to match the bromine. And that's looking pretty good because 2 potassium, 2 potassium, 2 iodine, 2 iodine, 2 bromine, 2 bromine, yeah. So 1 mole of bromine, and then if we add 2 moles of potassium iodide, there'll be a single replacement reaction, leaving us pure 1 mole of pure iodine and 2 moles of potassium bromide. Moving on to the next one here. Again, these two are going to change places, and you know, you got a metal, chlorine's a non-metal, so those two have to go together. FeCl, well, we better get, go out, look on our periodic table, find the chlorine. Again, it's group 17, they're always -1, they always want to take 1 electron. Now, iron is multivalent, but it's going to be iron 3 if we don't tell you, so it's going to be the most common form. So you're going to need 3 chlorines, right, to balance that off, 1-to-3 ratio. For FCl, it's going to be 3, it'll form a solid, and that'll kick out hydrogen gas, H2, right, because if the hydrogen gets kicked out, it's H2 gas. Now let's see about balancing this. Now we could just go ahead and balance that chlorine, but if I put a 3 there, that's not the correct for the hydrogen. So we right off the bat know that we're going to need to have a common multiple between 2 and 3. So therefore, we're going to need to put a 2 here. Okay, so 2 times 3 is 6. So we're going to need to go and put a 6 there, right? Because we've got to have 6 chlorines, and 2 times 3, 6 chlorines. We've got a lot of hydrogen, but we just put a 3 here. Oh yeah, 3 times 2, starting to balance, right? And now it's just the iron, 2 right there. Check if this is in its simplest form. It can't have any fractions. So 2, 6, 3, 2. That's interesting. Could this be 1, 3? Could we divide this all by 2? Oh no, we can't. Just about thought I could. Because 2 and 6 divide, but if I try to divide this by 2, that'd be 1.5. So indeed, this is its simplest ratio. 2 moles of iron plus 6 moles of hydrochloric acid will yield 3 moles of hydrogen gas and 2 moles of iron chloride. Cool, awesome. Okay, and I believe the next one that I had here, yeah, that's going to be a double replacement, so we'll look at that next. That's how to write and balance these single replacement reactions. Try these 3 on your own. Again, Science 10. Take care.